Okay, here we go. We are looking at, this is 2017, number 3. Okay, this problem is without a calculator. Okay, let me see something here. Okay, so the function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 is equal to 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Find the values of f of -6 and f of 5 in part A. What do you think we're going to have to do in part A? Okay, so in part A here, because we are given some function values that we need to find, what we're going to do is we will use the fundamental theorem of calculus to help us find those values. Okay? All right, so if I want f of -6, then let's think of what the fundamental theorem of calculus says. It says that if I take the integral of f prime, this will get me f of x. Okay? And what we're going to do is we'll use the initial value that it gives me, and we'll use one of these values that we're trying to find. So this integral, this one in particular, will go from -6 to -2, and I'll evaluate my function from -6 to -2. Okay? Okay, so let's keep going with this line here. So -6 to -2, f prime of x dx equals f of -2 minus f of -6. And we're going to plug in the information that we know. Or what are we trying to solve for, I guess? That's the better question, is we're trying to solve for f of -6. So let's see if we can get f of -6 by itself. So I'm going to add f of -6 to the other side, and then I'll subtract the integral. Okay? F of -2 was given to us in the beginning of the problem. F of -2 is equal to 7. So that equals 7 minus this integral. And now let's think about what this integral represents. Do you remember what it represents? That's the area under the curve. Okay, so we're going to find the area under the curve from -6 to -2. Now, if I had an equation, I would just be finding the antiderivative, but I don't have an equation. Instead, what I'm given is the graph of f prime. Okay, so let's find the area under the curve from -6 to -2. Okay. This one's just a triangle. 1/2 base times the height of 2. 2's would cancel out. I'd get 4. So I'm going to go ahead and write that down here with my work as well. But 7 minus 1/2 times 4 times 2. 2's cancel out. I'm left with just the 4. So 7 minus 4 is 3. So f of -6 is 3. Okay? We're going to go through the same process, but now with 5. So I'm still going to use what was originally given, the -2, and this time I'm going to go to 5, and it's the integral of the derivative would equal my original function evaluated from -2 to 5. Okay? So we'll plug in the top bound minus plug in the bottom bound. Okay? And we're trying to solve this for f of 5. So I'm just going to add over that f of -2. Okay. F of -2, like we already talked about in the last problem, was 7. And I'm going to add on the area under the curve of f prime from -2 to 5. Okay. So let's go up to my picture again. From -2 to 5, I'm going to erase what I already put up there. So from -2 all the way to 5 here. Okay. I've got a semicircle and I've got a triangle. All right, so I need to find the area of each of those shapes and add them together. For the semicircle, it's half of a circle, pi, radius squared, plus, well, and that's below the x-axis, so I should include a negative, plus the area of the triangle, 1/2, let's go back to that triangle for a second, 1/2 base, which is 3, times the height, which is 2. So 1/2, 3 times 2. Okay? Let's keep going and see what we get. So 7 plus the 2. One of the 2's there would cancel with one of the 2's there, so that'd just be a 2. So that's negative 2 pi. Plus the 2's cancel. I'm left with 3. Okay? So 10 minus 2 pi would be what f of 5 equals. Okay? All right. Part B. On what intervals is f increasing? So let's think about when is a function increasing. Part B. F is increasing when? Do you remember? When the first derivative is greater than 0. Okay? So I'm going to go up to my graph. I'm going to look for everywhere where the first derivative is greater than 0. In this case, because I have a graph, we're looking for where it's above the x-axis. Okay? So this graph is above the x-axis from -6 to -2, and it's above the x-axis from 2 to 5. So let's go ahead and put those. So it's when f prime is greater than 0 on, and we're going to say from -6 to -2, union with 2 to 5. Okay? All right. Part C. Find the absolute minimum value of f on the closed interval -6 to 5. Okay, do you remember how you find a minimum value on a closed interval? Yep, we're going to use a candidate test. All right. So for a candidate test, we're going to start by finding the critical numbers. Critical numbers are when the derivative is equal to 0 or undefined. Okay. So the derivative is equal to 0 at 2 different places, at -2 and at 2. But if I want to find a minimum, then the minimum will only occur when the derivative changes from negative to positive. So we don't have to use both of these numbers, x equals -2 and x equals 2, because x equals -2 changes from positive to negative, it would be a maximum. Okay? And then at x equals 2, because it changes from negative to positive, I guess I should probably be consistent here, huh? Changes from positive to negative or from negative to positive, it would be a minimum. So because I'm trying to find a minimum, I don't have to test both of those critical numbers. The derivative is the undefined at pointing places. Now, these would also be considered pointing places because they're sharp turns, but I'd also have a pointing place at 3. Okay. Now, for the sake of finding a minimum, it's probably not going to be that point because the derivative doesn't equal 0. Okay, we're looking for places along the x-axis. Okay. It also says 5, but 5 is also an endpoint, so that's not going to be a number I'm going to list as far as my critical numbers go. Okay. Okay, so to find a minimum, we're going to use the candidate test. So I'm going to make a chart. I'm going to plug in my bounds. It says from -6 to 5. And I'm also going to try 2. Okay. And I'm going to figure out what their function values are. Now some of these we already found, and some of them we may need to find. Okay. It does tell us, wait, does it tell us anything? Let's see, we found f of negative 6. That was 3. We did find f of 5. F of 5 was 10 minus 2 pi. So the only one I have left to find is positive 2. Okay, so this time I'm going to do the integral from negative 2 to 2 of f prime of x. So I'll have f of 2 minus f of negative 2. The integral, well, let's see, we're trying to get f of 2 by itself, so let's move over that f of negative 2. Let's get that dx in there too. Okay. So f of negative 2 was 7 plus, and then from negative 2 to 2, from negative 2 to 2 is that semicircle. So minus 1/2, negative because it's below the x-axis, 1/2 because it's half the circle, pi radius squared. So this is just 7 minus 2 pi. Okay. If we're looking for a minimum, we need to kind of reason through these different answers. Let's see. I don't know why I put negative 3. That should have been a positive 3 there. I apologize. Okay, so let's kind of reason through these numbers. Remember, 2 times pi, that's going to be roughly 6. For kind of reasoning through these numbers, we can just think of pi as 3 because we don't get a calculator, right? So let's just kind of use our reasoning skills and think of pi as 3. So this is approximately 10 minus 6. And then this one would be approximately 7 minus 6. So which of those would be the lowest number? The minimum value is 7 minus 2 pi at x equals 2. Okay? Okay. Part D. For each of the following, for each of f double prime equals negative 5 and f double prime of 3, find the value or explain why it does not exist. So let's look at the second derivative of negative 5. So a second derivative is just the slope or the derivative of the first derivative. Okay, so on my graph here, let's get rid of the other stuff that I'd marked. At f equals 5, f prime of 5, okay, I want to find the derivative at the second derivative of 5. This is the graph of the first derivative. So the second derivative is just the slope at that point. Okay, got a couple different ways of reasoning through the slope, but it does go down 2, and then it goes over 4 because that's just a linear segment. So that slope is negative 1/2. Okay. Now let's take a look at the second derivative at 3. The second derivative, again, is just the slope of the first derivative. So at 3, what's the slope at that point? Well, it's a pointy place. So can you have a slope? Can you have a derivative at that point? And the answer is no. That derivative does not exist. That second derivative does not exist. The first derivative is 2, but the second derivative does not exist. Okay? And what we'll say does not exist because, and you can use formal definition, like your formal notation. I'll show you that in just a second, but for now we'll just say the derivative from the left doesn't equal the derivative on the right. Saying a pointy place would not be sufficient. Sorry for all the pop-ups. Okay. Good notation, like this is what they have on the AP exam. Okay, so this is like the best possible answer that you can ever give. But what that would look like would be the limit as x goes to 3 on the left of your slope. That would equal 2. And then the limit as x goes to 3 on the right of your slope of f prime. And you can kind of tie those together and say that this, let me get rid of that, that doesn't equal this. Oops. Okay, these are not equal. Okay, and that's just your definition of a derivative. You can use that. I think that this would be okay here, but to be extra formal, to be extra, you may want to include that second definition there. Okay. Okay, where's the 9 points come from? On part A is worth 3 points, 1 point for using this initial condition. If you use the fundamental theorem of calculus, you will include that initial value. Okay, and then 1 point for each of these. On part B, 2 points, all or nothing. 2 points for the answer with the justification. On part C, you would have 1 point for considering x of 2 being a critical number, and then 1 point with your answer and the justification, and the justification being here that candidate test. Okay. Part D is worth 2 points, 1 point for f double prime of -5, and 1 point for saying it does not exist with an explanation. You have to include that explanation. Okay? Let me know if you have any questions.